Hello my dear students, welcome to this lesson. So I'm going to continue with extra questions related to work, energy and power. So you know what work is. When you apply a force to an object, either the position changes or the shape changes, and then we say that there is work done and it is measured in the unit joules. Then there is energy, different forms of energy. The ability to do work is energy. That is also measured in joules. Under that, we discuss two types of mechanical energy, the kinetic energy and potential energy. Potential energy is the energy stored in an object due to its shape or the position. Then the kinetic energy is the energy gained or possessed by an object due to its motion. Both kinetic and potential energy, they also have the unit joules. Again, under potential energy, there are two types. One is gravitational potential energy. That is when work is done against the gravity. When an object is lifted up, we call that as gravitational potential energy gained by the object. If it is an elastic object, like a spring, when you stretch it, then there is energy stored in that object. That is known as elastic potential energy. Thereafter, we discussed power. What is power? The work done in a unit time. Basically, the work done in joules, unit time, that is 1 second. So, joules per second is the unit of power, but the standard unit is watts. So, those are the concepts we discussed in this lesson, and thereafter we did the miscellaneous exercise and some MCQ type questions. Now, I am going to discuss these questions. So, as I change each slide, I want you all to answer the question by yourself first, and then you can check your answer with my discussion. Extra question 2. Under that, the first one, what is work done? Like I just said, when you apply a force to an object, due to that force, there is a change in position or change in shape. Then we say there is work done. So, here we can say, work is done by an object when there is a change in position or shape due to the force applied onto it. So, when you apply a force, if the shape changes or position changes, we say that there is work done. So, work is done by an object when there is a change in position or shape due to the force applied onto it. So, that is what is work done. Then the second one. What is the SI unit of work done? SI unit is Standard International Unit. What is it? Joules. You all can remember it's named after the scientist Prescott Joule. So, you have to use the symbol capital J. So, this should be capital J in brackets. If I write it, it will be joules. That is the standard unit of work done. Then the next question. Write an equation to calculate the work done when a force is applied. So, you can remember, students, we consider an object. There is the object here. When you apply a force, the object moves from that position to the next position. So, here if we say this is the distance moved, and here the force applied, this has a certain mass, so that object goes to that position. There is a change in position. Change in position. So we apply a force and there is a change in position. That means there is work done. if you are to write the equation, work done equals magnitude of the force applied multiplied by distance moved by the object in the direction of the force. That is the complete equation, word equation to calculate work done. Work, or we can say work done, equals magnitude of the force applied multiplied by the distance moved by the object in the direction of the force. So from this only we get the unit joules as well. When magnitude of the force is 1 Newton and if the distance moved is 1 meter, the work done is 1 joule. We don't have to show that. This is just to recall what you have learned. So here you can see, write an equation to calculate the work done when a force is applied. So this is the equation. I'm sure you all also have written this correctly. So with that, students, we'll move on to the next slide. Extra question 3. So here they have given us a diagram. You all can see there is an object. So they have shown a force of 4 Newton acting on the object. So because of that, the position changes. And here the change in distance, or the distance between the two positions, is 1 meter. So that means you know there is work done. A force of 4 Newton was applied on an object placed on a horizontal plane as shown below. Why do we use this term horizontal plane? I'm sure you all remember, if the plane is inclined, there is the effect of gravity on it. Due to the inclination, the object can move faster. So there the work done will be different. You all know that if it is a flat road, you need to do work when you walk. But if it is a steep road, when you are coming down, you tend to move faster because there is the effect of the gravity. So that is why they always mention horizontal table, horizontal plane, so that there is no other effect except for the effect of the force applied. What is the work done by the force if the object moves a distance of 1 meter in the direction of the force? So what is the work done? We have already written the equation in the previous question, but again, work done is equal to force applied multiplied by distance moved by the object. Now students, you might be wondering, in the previous slide when I wrote the equation, I wrote the complete equation. Magnitude of the force applied multiplied by the distance moved by the object in the direction of the force. So that is when they ask you to write the equation, you have to give the full equation. But here, since we are going to do the calculation, if you write it in a short form, that is more than enough. You can even write it as force into displacement, because you all know displacement has a direction. So this particular displacement takes place in the direction of the applied force. So because of that, you can write it as displacement here. So work done, force into distance moved. So there, force applied is 4 Newton and the distance moved is 1 meter. So 4 into 1, it is going to be 4. If we write these two equations, Newton meter, but that gives you the standard unit joules. Newton meter is equal to joules. That also you all know. So is this okay, students? The calculation, to calculate work done, you need to multiply force by the distance moved by the object. 4 Newton into 1 meter. So that is 4 Newton meters. That's equal to 4 joules. I'm sure you all did it correctly. So we'll move on to the next question. Extra question 4. First one. What is energy? Energy is the ability to do work. So that's a simple answer. Energy is the ability to do work. Energy is the ability to do work. Then the second part of the question, what is the standard unit of energy? Again, work done, energy, any form of energy, the standard unit is joules. So here again, J, if you want to write it in words, joules. They have named the unit after the scientist. So joules. Work, types of energy, everything has the same standard unit, that is joules. But we saw before, work done, Newton meter equals joules. So those are equal units. But the standard unit is joules. Is that clear to you all? So then we'll move on to the next slide. Extra question 5. Write different forms of energy that help us to do work. We have discussed a few types of energy. Now when I'm talking to you, you can see me, so that is because of light energy. You can hear me because of acoustic energy, or what we call as sound energy. So 2 forms, light energy, sound energy. You are learning online. So obviously you are either using a mobile phone, computer, laptop. So that needs electricity. Then what is the energy related to that? Electric energy. That is electric energy. You all know temperature. Temperature is due to heat energy. So there is heat energy. Then there is magnetism. Due to magnetism, there is magnetic energy. Magnetic energy. And then the energy that we discussed. Mechanical energy, again there are 2 types, kinetic and potential energy. Under potential energy also gravitational potential energy, elastic potential energy. But all together we call it as mechanical energy. So mechanical energy. Mechanical energy. Light energy, sound energy, electric energy, heat energy, magnetic energy and mechanical energy. These are different forms of energy that help us to do work. With all these, we do work. That is why when you keep on listening to something, when you keep on looking at the lesson for a very long period of time, since you are doing work, to perceive these energy also you need to do work. So there also you get tired because of that. Again, electric energy, heat energy, those also help us to do different forms of work. You can remember heat energy is needed to rotate the turbine. So their work is done. That is in thermal power plants. Then electric energy, so many things. If you switch on the fan rotates, then electric energy is used to do work. That is to rotate the fan. Magnetic energy. You will be learning this in your next grade. There is the dynamo, the motor. So all these use magnets. There again magnetic energy can be used to do work. Then mechanical energy we have discussed so far. I'm sure you have written all these energies in your answer. Then here. The next question, that's part 2. Write the 2 types of mechanical energy. I have already told you all that. What are the 2 types? The potential energy and kinetic energy. Potential energy. Potential energy. and kinetic energy. The two types of mechanical energy. Is that okay, students? So then let's move on to the next slide. Extra question 6. A glass ball with smooth surface is kept on one end of a smooth inclined plane as shown in the diagram. So if you look at the diagram, here you can see the flow level is marked, that's the inclined plane, that's marked U, and this particular level is marked as A, and here the flow level is marked as B, but the glass ball is somewhat above both A and B levels. And here they have said smooth surface of the glass ball, and the inclined plane also has a smooth surface. You all know the reason why they mentioned this. When we say smooth, we have discussed friction before. Normally rough surfaces have more friction. So then to move the object, you all might need to expend some amount of energy. You all know that when there is more friction, energy is lost in the form of heat. So here when they say smooth, both are smooth. The glass ball has a smooth surface, the inclined plane is also smooth. So because of that, we can assume that there is no energy lost due to friction. So that is why they mention all those terms there. The ball moves from that point towards point B. So from this point, it moves towards point B until it reaches this ground level. And here you can see the height is marked as h. From this point B to this point, the height is h. So that is the information you can get from the diagram. If we look at the questions, what type of mechanical energy is stored in the glass ball shown in the diagram? So there, if it is at a height, now there's this vertical height and the inclined plane. At the top of the inclined plane, what is the energy stored? It is potential energy, and also because it is work done against the gravity, we call it gravitational potential energy. So you can write the answer as potential energy, but to be more specific, it's better to write it as gravitational potential energy. So it is gravitational potential energy. Potential energy. Gravitational potential energy. Energy stored in an object due to its position, and here because the work is done against the gravitational acceleration, it is gravitational potential energy. Then we'll move on to the next part of the question. The same diagram I have already explained to you all. So if we look at the second part, the mass of the glass ball is m and the gravitational acceleration g. Write an expression for the mechanical energy possessed by the ball when moving towards point B. So the mechanical energy possessed by the ball when moving towards point B. That is very important. So when it is moving, initially it is potential energy, and when it is moving, the potential energy will be converted to kinetic energy. So what is going to be the energy when the ball is moving down? It is the kinetic energy. Kinetic energy is what? Half mv squared. So here we can say when moving, it possesses kinetic energy. So that is E kinetic equals half m v squared. They have given m, they have given g, but they have not given v. So that means we need to define v as velocity of the glass ball when moving. So that is V. Half mv square. That is the equation. So then the next part. Is that okay, students? They have asked the question when the object is moving towards point V. So when it is moving, there will be a certain amount of potential energy, but mainly it's going to be kinetic energy. Why? The potential energy that was stored when the glass ball is at the top of the inclined plane will be converted to kinetic energy. So you have to remember that. Then write the energy transformation when the ball rolls from point A to point B. So from here to here also there is a certain amount of potential energy that will be converted to kinetic energy because the object is rolling. So there they want you to write the energy transformation. Potential energy to kinetic energy. So that is the energy transformation that is taking place. So with that, we'll move on to the next part of the question. Fourth one, again the same diagram is given to you. The ball reaches the ground with a velocity v. Write an expression for the kinetic energy of the ball when it reaches the ground. We have already written that, but here they have again said when it reaches the ground, the kinetic energy is v. So we need to write an equation for that. Kinetic energy. So here, kinetic energy equals half mv squared. So that is E kinetic equals half mv squared. That is the equation there. Then the fifth part. What is the advantage of the inclined plane having a smooth surface? I discussed that with you all before also. What is the advantage of having the smooth surface? It reduces friction, so we can assume that there is no energy lost due to friction. So here we can say smooth surface reduces friction. Therefore, we can assume that there is no energy lost due to friction. Is that clear, students? Because the surfaces are smooth, the friction is less, or we can say there's no friction at all. So because of that, we can assume that there is no energy lost due to friction. So that means all the potential energy that is stored in the object at the top will be converted to kinetic energy at the bottom when it reaches the bottom. That is point B. Is that clear to you? So then we'll move on to the next slide. Sixth part of the question and the same diagram again. So if we look at the question there. When is the kinetic energy of the ball maximum at point A or point B? Now here you can see kinetic energy is E kinetic is 0 here because at this position ball is at rest. But when it is moving down, at this point there will be a certain velocity. You all know, although it is coming down the inclined plane, there is an effect of the gravitational acceleration. As it goes down, the velocity will increase. So because of that, if we write this as VA, this as VB, VA will be less than VB. So because of that, the kinetic energy at this point will be the maximum. Why kinetic energy is half mv squared. Mass is the same, kinetic energy depends on velocity. So since Vb is greater, kinetic energy will be highest there. So when is the kinetic energy of the ball maximum? At point A or point B? It will be the maximum at point B. At point B. Why here? Kinetic energy depends on half mv squared. So this is constant. So kinetic energy is directly proportional to v, velocity. Velocity is high as it reaches the ground. You all can remember, if you throw something up, when it comes down, as it comes down, due to gravitational acceleration, the velocity increases. So here also, although it's not coming down directly vertically downwards, still there will be an increase in velocity. I'm sure you all have experienced that before as well. So at point B, the kinetic energy will be higher compared to point A. Then the next question, next part of the question, part 7. The mass of the ball is 500 grams. So mass is given as 500 grams. Normally you all know, students, when they give it in grams, you all have to use all standard units. So we need to convert it to kilograms. So mass is equal to 500 divided by 1000 kilogram. That is 0.5 kilogram. Like I told you all before during the lesson also, you can do the conversion here and substitute, or you can substitute with the unit conversion. In the equation itself, you can divide 500 by 1000. It's up to you all. Whatever method is easy for you, you can follow that method. And the vertical height is 5 meters. So their height is 5 meters. You can see what is the potential energy stored in the object in the diagram. That is, gravitational acceleration is 10 meters per second square. That is 10 meters per second square. So what is the equation for gravitational potential energy? Potential energy that is E potential equals mgh. That is the equation. Mass into gravitational acceleration into height. So if we do the calculation, E potential, we have already converted the mass to kilogram, 0.5 kilogram into 10 meters per second squared gravitational acceleration, and height is given to us as 5 meters. So then, if we multiply 0.5 into 10, 5, 5 into 5, 25. So that is going to be 25 joules. 25 joules is the potential energy or the gravitational potential energy gained by the object. So if we look at the questions again, here I explain why at point B the kinetic energy is more. And here we were supposed to calculate the gravitational potential energy. So here m is 0.5 kilograms into 10 into 5, that is 25 joules. Or else, like I told you all before, students, you can do it where you can do the substitution and calculate. So the other way it's the same thing. E potential, you can write it as 500 divided by 1000 kilogram into 10 meters per second squared into 5 meters. Still you get the same answer. Here also you can simplify 5 into 5, 25 joules. Whatever method you use, it's fine. You can calculate, do the unit conversion before and substitute, or you can do it together here. But you will have to get the same answer. That's very important. I'm sure you all did all these calculations correctly and you also got the same answer. So then we'll move on to the next slide. That is part 8 of the question. Find the velocity of the ball when it reaches the ground. How do you do that? find the velocity of the ball when it reaches the ground. Now here we calculated E potential as 25 joules. What happens there? Here velocity is 0. Kinetic energy is 0. Here there is a velocity. If you can remember, there is no friction. We said smooth surface, smooth ball, no friction. So we assume that there is no energy loss due to friction. So that means all this potential energy will be converted to kinetic energy there. So E kinetic will be equal to 25 joules there. Then you can find the velocity. So when you answer the question, you have to say it can be assumed that the potential energy is completely transformed into kinetic energy. That is kinetic energy at point B equals 25 joules. Then we know the equation E kinetic equals half mv squared. So there E kinetic 25 joules, half. So we need the mass of the glass ball. In this previous slide we have calculated that. Here I showed you all. You can either do the unit conversion with the calculation or you can do it before. So it is 0.5 kilogram. I will use that value here. So here that is going to be 0.5 kilogram into V squared. So to make it easier, I will do this as half and this also I will write it as half into V squared. So we need to find V squared. V squared, if you rearrange, 25 into 2 into 2. So V, you need to get the root of 25 into 2 into 2. So you all know root of 25 is 5. 2 into 2, so that's 2 squared. So that the root of that is 2. It is going to be 5 into 2. So that is 10 meters per second. So velocity is 10 meters per second. Is that clear to you all students? So we came to this answer because we assume the ball is smooth, the surface is smooth, so there is no friction, no energy loss. Therefore, all the potential energy is converted to kinetic energy. So when that happens, we have calculated the potential energy to be 25 joules. And that 25 joules is equal to kinetic energy. So that is half mv squared. Half into m is 0.5 into v squared. But for convenience, I use it as half itself. Half into half kilogram into v squared. So when you rearrange, v squared is equal to 25 into 2 into 2. If you get the root, you get the square root, you get 5 into 2. So that is 10 meters per second. So I am sure students, you all can understand this calculation easily. So with that, I am going to move on to the next slide. Extra question 7. An object of mass 3 kg was lifted to a height of 3 meters as shown in the diagram. So there you can see this diagram. 3 kilogram goes to a 3 meter height. So you all know the weight is acting downwards. That is going to be mg. And that is the force that is needed to be applied in order to lift the object up. So you know the force, you know the height, the distance moved by the object. So you know the work done. Or else if they ask you for the potential energy gain, you know mgh. M is the mass, 3 kilograms. G is gravitational acceleration and h is the height lifted. So either way you can calculate it. If we look at the questions, what is the force required to lift the object up? Gravitational acceleration is given as 10 meters per second square. So the weight of the object, weight equals mg, that is equal to 3 kilogram into 10 meters per second squared, that is equal to 30 Newton. So force needed to lift the object is equal to 30 Newton. That is the force required. Then the second part of the question, what is the work done when the object is lifted to a height of 3 meters? So you need to write the equation for work done. Work done, force applied into height lifted. So that will be equal to force applied is 30 Newton and the height lifted is 3 meters. So that is going to be 90 Newton meter, which is equal to 90 joules, the standard unit of work done. So here, now these are step-by-step questions so that you can understand it easily. What is the force required to lift the object? That is equal to weight. Weight is mass into gravitational acceleration. So 3 into 10, 30 Newton. That is the force needed to lift the object. Then the work done is force applied into height lifted. So 30 Newton into 3 meters. That is 90 Newton meter. That's equal to 90 joules. So you all would have answered these two correctly. We'll move on to the next part of the question. Third part, again the same diagram is given to you, so you all know what it means. What is the potential energy stored in the object when it reaches the height of 3 meters? Now for this question, students, you can answer it in two ways. How? Potential energy is gained by the work done against the gravitational acceleration. So we have already calculated work done. That is 90 joules. So you can write it directly. That is one method. So here, potential energy gained, energy equals work done against gravity. So because of that, we have the value as 90 joules. We already calculated it in this previous one. Here you can see 90 joules. That is the work done when the object is lifted up. So that is the answer here. Or else you can write it this way. Or you can say E potential equals mgh. There you know the mass, 3 kilogram, g 10 meters per second squared, and the height h 3 meters. So that also will give you the same answer. 3 into 3, 9 into 10, 90 joules. So either way, you will get the same answer. Since we have already calculated, you can directly write this. The work done against gravity is equal to the gravitational potential energy gained by the object. So that is equal to 90 joules. Or else you know the equation. E potential is equal to mgh. Mass into gravitational acceleration into height. So 3 into 10 into 3. That is 90 joules. Either method is fine. So then, the fourth part. Why is the energy stored in the object known as gravitational potential energy? Why do we call it gravitational potential energy? You all know the reason. What is it? Because the energy stored is due to the work done against the gravity. So that is what you have to write. It is the energy stored in the object when work is done against gravity. That is by lifting the object upwards. So that is why we do work against gravity. So that is why it is known as gravitational potential energy. It is the energy stored in the object when work is done against gravity. That is by lifting the object upwards. If you want that, you can say that is why the energy is known as gravitational potential energy. That is to complete the answer. That is why the energy stored is known as gravitational potential energy. So here students, this is a complete answer, that is a complete paragraph. But when you are going to answer a question within a short space, within a small space given to you, it is perfectly fine if you stop at this point. You don't even have to say by lifting the object upwards. If you simply say it is the energy stored in the object when work is done against gravity, that gives all the required information. That is the most important part of this question. So if you all are to write short answers, stick to only that. This gives you a complete explanation to complete the paragraph. That is why I have written this here. I am sure you all can understand that clearly. So with that students, I will move on to the next slide. Extra question 8. An object with mass m moves with a velocity of v in a linear path. The first question. What type of energy is possessed by the moving object? Obviously, you all know it's a type of mechanical energy, that is kinetic energy. Energy possessed by an object due to its motion. And that energy depends on what? Both mass and velocity of the object. So there they have given us the mass and velocity. And it says linear path, so you know it's a linear motion. So the energy is kinetic energy. We have to answer it as kinetic energy. Kinetic energy. Second part of the question, write an expression for the energy you mentioned above. You all know the expression, kinetic energy that is E kinetic equals half mv squared. That is a direct question. E kinetic equals half mv squared. depends on mass and velocity. When the mass increases, kinetic energy increases. When velocity increases, also kinetic energy increases. I'm sure you all wrote these correctly, students. With that, I'll move on to the next question. What will happen to the energy possessed by the object if it slows down? So what will happen to the kinetic energy if the velocity decreases? When you say slow down, the velocity decreases. Therefore, the kinetic energy will decrease. So here you can say, when the object slows down, the velocity will decrease. Then the kinetic energy decreases. So this is the important part. Kinetic energy decreases. So the question is, what will happen to the energy possessed by the object if it slows down? So the energy will decrease. The reason is, when the object slows down, you all know that is the velocity is decreasing, and kinetic energy is half mv squared. So kinetic energy is proportional to velocity. So when velocity decreases, kinetic energy will decrease. That is what you need to write. So again, like I told you all before, students, if it is a short answer question, you just write decreases. If they ask you to explain, you have to give this explanation. I have written down everything so that you recall and understand what happens there. Is that clear to you all? So then I'll move on to the next slide. Extra question 9. A child with a mass of 45 kg climbs up a staircase as shown in the diagram. So we'll look at the diagram first. So here you can see, students, the child is climbing up the staircase. Now the length of the staircase is given to you as 10 meters. But you can see the vertical height from this point up to here, that is 6 meters. So although the staircase is longer, the height between the bottom step and the higher step, you can see that's the vertical height that will be short. You all know that. Even from maths, you all know this is like a triangle shape. So obviously this side is shorter than this side. This side will be always long. You all know that. So here, if we are to calculate work done or calculate potential energy gain, we need to consider this height, not this length. The length of the staircase should not be considered there. Is that clear to you? So then, if we go back to the question, you can see the vertical height from the floor to the last step is 6 meters. First question is, what is the weight of the child? So you all know what is the equation for weight. Weight is equal to mass into gravity, G. So their mass is 45 kilograms and gravitational acceleration, you all know, 10 meters per second squared. The exact value is 9.8 meters per second squared, but normally for calculations, we take it as 10 meters per second squared. Even though they don't give it in the question, you all have to know that value, students. Normally in the paper also, at the beginning of the paper, they might give you the value. If not also, you have to remember the value for gravitational acceleration. For calculations, we take 10 meters per second squared. So that is going to be 450 Newton. That is the weight of the child. Then, if we take what is the potential energy gained when the child reaches the last step. So what is the potential energy gained? Potential energy gained can be, it is equal to E potential, and E potential is calculated as mgh. So there. What is M? 45 kilogram. G 10 meters per second squared. And H 6 meters. As I told you all, we only take the vertical height, not the length of the staircase. So there. 45 into 10 into 6. So that's going to be 450 into 6 joules. That will be equal to 0, 0, 5 into 6, 30. So 0, 3, 24 plus 3, 27. So 2700 joules. That is the energy, potential energy gained when the child walks from the bottom step to the top step. This is one way of calculating. Like I told you all before, if you know the work done. Work done is weight of the child into the height moved. That is the vertical height. Directly also you can multiply 450 by 6. This step. If you don't write this equation, if you write potential energy as work done, you can directly write this step. We have done that in one of the previous questions. Either way, you will get the same answer. I'm sure you all remember that clearly. So 2700 joules is the potential energy gained when the child reaches the last step. Is that clear, student? So then we'll move on to the next slide. That is extra question 10. The position of an object can be changed by applying a force. That you all know. Position of an object can be changed by applying a force. That is when the work is done. So how do we calculate that? Position of an object can be changed by applying a force. The first question, write an expression to calculate the work done when the position of an object is changed by applying a force. So you have to write the full equation. Work done is equal to magnitude of the force applied multiplied by the distance moved by the object in the direction of the force. So that is the complete equation, students. Before also in one of the previous questions, I told you all, when they ask you to write the equation or the expression, you have to write it completely. Work done is equal to magnitude of force applied multiplied by distance moved by the object in the direction of the force. But when you are doing a calculation, you can simply write it as force into distance, or force into height lifted, or even force into displacement. Because you all know distance moved in a particular direction, the direction of the force will give you displacement. So that also can be used there. That is when you are doing a calculation. But when you are asked to write the expression, it is always better to give the complete expression. Is that clear to you all? So then we'll look at the second part of the question. An object moves a distance of 50 centimeter when a force of 12 Newton was applied. What is the work done? An object moves a distance of 50 centimeter. We have done this type of questions. You can remember the object being here. Then the object comes to a different position. This is 50 centimeters. So here the force applied is 12 Newton. So if you are to calculate work done. So here we can easily write the short equation. Work done, force into displacement. Or we can even write it as F into S, the displacement. So there you can see 12 Newton force, but the displacement, that should be in meters. So again, like I told you, you can either do the unit conversion before and substitute, or substitute. It is 50 centimeters. 50 centimeters divided by 100 meters. Either way is fine. So if we do this, you will get the answer as 2. So 2 and 12, 6. 6 joules. That is the work done. 6 joules of work is done. If we go back, first we wrote the equation for work done, the complete equation. Then this question, like I told you all, this is the change that is taking place. The object is moving. The position changes by 50 centimeters. Force applied is 12 Newton. So work done is force into displacement. That is F into S. 12 Newton force. You need to do a unit conversion. 50 divided by 100. You get the answer as 6 joules. That is the work done. So with that, students, I have come to the end of this chapter. So here I have discussed about 10 extra questions, but in the next chapter also I will be discussing some more extra questions.